not because of the process, but because sometimes you have a lot of different terms that you're ending up with that you have to sort through. Okay, so what we have to remember about these is that if I'm looking at a binomial times a trinomial, just like we talked about back here, we want the A to distribute to everything, and we want the B to distribute to everything, okay? So if I'm looking here, I want this part, the 3A, to distribute to everything here, okay? So if I multiply these through, I'm just going to go ahead and do that. I'll have 3A to the third plus 12A squared plus 15A. Okay, so I've multiplied my 3A times everything, all right? Now, this is going to be the organizational piece that might help you to keep everything sorted, okay? I've done that part. Now I need to multiply this part by everything here, okay? When I do this, I see that the first part that I multiply gives me a negative 2A squared. Now, rather than, and you could, but rather than line it all up on the end here, going across my paper, I'm going to put my negative 2A squared with the other A squared, okay? Then when I'm combining everything, I know these are like terms. I just can see that they're all right here, okay? Okay, so negative 2A squared. Now the second part gives me negative 8A, and then negative 2 times 5, negative 10, okay? Now it comes down to combining. So if I want to combine these, I see that there's only one part that has an A squared, one term. So 3A cubed. There are two terms that have an A squared. I have a positive 12 and a negative 2. That gives me a positive 10A squared. Now I have a positive 15 and a negative 8, positive 7A. And then this number over here with no variable, I just have just that one number. Okay? And there's my solution. Okay? Nothing else can be combined. I kept all my like terms together so that I could easily combine them into a final solution. Okay? So let's look at the one down below, okay, because this is pretty exciting. Look at that, trinomial times a trinomial. I know you're pretty excited too. So let's start off multiplying our x squared. Now we said that we have to multiply it by all three parts. So x squared times x squared, I'm going to have x to the fourth. X squared times x plus x to the third. Then I have x squared times negative 5, negative 5x squared. Okay. Now I'm going to go to my negative 3x. Okay. And I'm going to multiply that by everything. Now my first one here, my first product, negative 3x times x squared, is going to give me negative 3x to the third. So if I organize this here, negative 3x to the third, I'm going to line this x to the third up underneath the other x to the third. Okay, so now they're together. I multiply times the second one, negative 3x times x. It's going to give me negative 3x squared. Then negative 3x times negative 5 gives me a positive 15x. Okay. Ooh, we're almost done. Okay, we have one more part here. We have this 2 that's going to multiply times all three parts. So this one, 2 times x squared, my first product is a positive 2x squared. My x squareds are here, so I have a positive 2x squared. Okay, 2 times x gives me a positive 2x. 2 times negative 5 gives me minus 10. Okay, now look how nice and organized this is. If we, and like I said, you can do this, but if we have everything in a row, it would stretch nearly across the whole entire page. And you can do it, but this is a little bit better organization so that you have everything together. Because now, if I'm combining all of this, I can see there's only one x to the fourth. Oh, I keep forgetting that this pen is dead. Okay, hold on, guys. I've already started with green, so I'm gonna, here's the other green. This one's fresh. Okay, so we have x to the fourth. All right, now I have a positive x to the third x to the third, and then negative 3x to the third. That gives me negative 2x to the third. Okay, now we have three things here. Negative 5 minus 3 is negative 8, plus 2 is negative 6x squared. 15 plus 2 plus 17x minus 10. That is a 10. Okay, and there it is. That is our final solution. There are no other terms that we can combine. We already kind of know that because we kept all the terms that could be combined grouped together. Okay. Alrighty. Oh, let's move on. Okay. Now we're gonna do one last part here, and then you can work on the application. Okay. All right. Now we talked not yesterday. We talked at the start of this lesson about functions, sum functions and difference functions. This function here is a product function, okay? F times G, all right? Now, again, we have two different functions, F and G. If we want the equation of the product function, F times G, then what that means is we're going to be taking our function F, which is 3x plus 7, and we're going to be multiplying it by our function G, which is 5x minus 2. Okay, we use traditional FOIL here. Multiply our first terms together. Gives me 15x squared. Outside, minus 6x. Inside, plus 35x. And the last, minus 14. Okay, these two are like terms. So I have 15x squared. Negative 6 plus 35 gives us plus 29x minus 14. Okay, oops. We need to write F times G equals this. So this is our product function, okay? Now, with this product function equation, now we go down here to find F times G of 2. So if we want F times G of 2, that meant that we take 2 and we substitute it in for x, okay? So F times G of 2. So I'm going to have 15 times 2 squared plus 29 times 2 minus 14, okay? I know that I need to apply my exponent first, so now I have 15 times 4 plus 29 times 2, 60, 58, minus 14. 15 times 4 is 60, plus 58 minus 14. That'll give me 110, 118, minus 14. I'm going to write that part down. 118 minus 14 gives me a solution of 104. F times G of 2 equals 104. Okay, that is my solution. Okay. Now, there is one other thing that I would like to show you, and it's something you guys might have been thinking about since I started the FOIL part. And I think that I'll just use this item right here. 3x plus 7 times 5x minus 2. Okay. Now, the other thing that I wanted to mention is that there is another strategy that you can use for these called the box method. Okay. You may or may not have learned the box method. You may or may not like the box method. It is not necessary, but if you prefer the box method over this, then you can use the box method. Now, the box method is kind of an area model of multiplication. So if I put 3x plus 7 on one side, and then 5x minus 2 on the other side, I multiply them together. So when I'm multiplying this side times this side. So this gives me 15x squared. This times this gives me 35x. This times this gives me negative 6x. And then this times this gives me negative 14. Okay? So here we look diagonal at the different parts. Okay? And I end up 15x squared plus 29x, because I'm combining these two, minus 14. Now, you can see this is the same solution as what we got up here. Okay? It just lays it out a little bit differently. And when you're working with some of the larger ones, let me put like this one on here. This was, okay, sorry. This is a little bit bigger. I'm gonna have the video over here. So there we had x squared minus 3x plus 2, and we had x squared plus x minus 5. Okay, so this is a 3 by 3. I guess I didn't quite need it, the box that big. Okay, but the idea is the same. This times this, x to the 4th. This times this, negative 3x to the 3rd. This times this, 2x squared. This times this, x to the 3rd. This times this, negative 3x squared. This times this, 2x. This times this, 5x squared. This times this, 15x. This times this, negative 10. Okay, now again you see these are our parts, our terms that can be combined. Okay, there's only one x to the 4th. We have these two minus 2x cubed, these 3 minus 6x squared plus 17x minus 10. Okay, and again, this is the same solution as this right here. But you have an option. Which of these strategies makes the most sense to you? Which one works the best? You're welcome to use either one. It doesn't matter to me as long as you have a strategy that you're comfortable with and that you feel confident replicating in different problems. Okay? So, the only other thing left in this section is this problem here, this product function. And I think that, I think what I'd like you to do is give this part a try, and then I'll show you the solution first in tomorrow's video, and then kind of talk about what it means, okay? So that's it for today, guys. I have to head off to my conference now, so I will talk to you later. Okay, bye.